Welcome back, everyone. That week in April, we're talking April 8th through the 15th, 2025, it really felt like something shifted in tech, didn't it? Especially with AI.
Oh, absolutely.
Yeah.
It wasn't just the usual step-by-step progress. It felt more like a sudden jump forward, a real acceleration.
Yeah, almost like a technological Big Bang kind of compressed. And for this deep dive, we've been digging through all the announcements, the research, everything from that specific week.
And what's striking is how it all seems to cluster around maybe three big themes.
Exactly.
Yeah.
First, there's this huge surge in what people are calling AI agents. These aren't just chatbots anymore. They're systems meant to actually do things autonomously.
Proactive systems.
Right. Second, the hardware powering all this AI. Massive news on the chip front, big investments, new tech.
The engine behind it all, really.
And third, we saw AI getting woven much deeper into the software we use every day, making things smarter, more seamless.
And maybe even glimpses of what's next, like AI intersecting with quantum computing, with robotics, stuff that still feels a bit sci-fi, but is getting closer.
Definitely. So the plan is to unpack the most important bits from that week. We want to lay out what actually happened, why it's significant, why you should care, and what it might mean for all of us pretty soon.
Sounds good. And maybe the place to start is with those AI agents. What makes them agentic? How are they different from, say, the chatbots we've gotten used to?
That's the key question, isn't it? We're moving past just responsive systems. These AI agents, they're designed to understand a goal, maybe a complex goal you set, and then figure out the steps and take action to achieve it with minimal handholding from us.
Right. So less prompting, more autonomy.
Exactly. And it's not just theoretical. Forbes actually put out a prediction around then saying that by 2028, something like a third of all enterprise software will have this kind of agentic AI built in. Think about that for businesses.
That's a huge shift. And we saw several companies jumping into this space during that week, right? Different angles, different approaches.
Yeah, quite a few. Let's start with Tableau from their Tableau Next T event. Anyone who works with data knows about that. That feeling of uncertainty sometimes. Is the data clean? Can I trust the insights? They called it the data confidence gap.
Okay, and they're tackling that with agentic analytics.
That's the term they used. And it involves three specific AI agents. First, there's Data Pro. This one's all about automating the grunt work, cleaning data, preparing it, transforming it. Imagine the time saved there. That's supposed to be out June 2025.
Okay, so automating the prep. What else?
Then there's Concierge. This sounds really useful. You basically ask questions about your data in plain English, and it gives you insights, charts, visualizations right away, also aiming for June.
Natural language querying. Got it.
And the third one is Inspector. This one's more proactive. It kind of watches your data in the background, looking for hidden patterns, outliers, anomalies you might not even think to look for. That one's coming a bit later in 2025.
And Tableau is careful to position these as tools for analysts, right? Not replacements.
Absolutely. They stress that it's about augmentation handling the routine stuff so the human experts can focus on the bigger picture, the strategy, the interpretation, making analysis faster and maybe more accessible.
Makes sense. Okay, who else was making noise in the agent space?
Well, there was the no-code automation platform. They launched Make AI agents in beta. This feels like bringing that agent power to, well, almost anyone.
Right, because Make is all about building workflows visually without code.
Yeah.
So how do the AI agents fit in?
They bring real-time smarts into that visual builder. These agents can understand natural language instructions, which is huge. They're aware of the context of the workflow, and they can actually adjust the workflow on the fly based on what's happening.
Dynamically adjusting automation.
Yeah.
That's interesting.
Yeah. And they connect to tons of other tools. They mentioned integrations with Perplexity for search, Sky for marketing automation. They said it connects to over 2,000 apps, something like 30,000 possible actions.
Wow.
So you could visually build, say, a marketing campaign that adapts based on real-time customer clicks, or a support process that changes its steps based on how frustrated a customer sounds, all built visually.
That really lowers the barrier to creating some pretty sophisticated, intelligent automations. You don't need to be a coder.
Definitely. Then, switching gears a bit, we had OPPO, the smartphone maker. They were at the Google Cloud Next event talking about their own agentic AI initiative.
So bringing this agent concept directly onto mobile devices.
Exactly. They're working with Google Cloud. They showed off AI Search, which is like a system-level search tool. You can use natural language to find anything on your phone, text, photos, documents, whatever.
That sounds handy, like a universal search.
Yeah. And they're also building a user knowledge system. Basically, the phone learns your habits, your preferences over time to offer more personalized AI features. Hyper-personalization, they called it.
And privacy is always a concern there. How are they addressing that?
Good point. They announced their private computing cloud, or PCC, which uses Google Cloud's confidential computing. The idea is to process the AI stuff securely, keeping user data private.
That's crucial for trust. And they have ambitious plans for rollout.
Huge plans. They're aiming to get these AI capabilities onto nearly 100 million devices by the end of 2025. That's a lot of users potentially getting agentic AI experiences soon.
That scale is significant. Okay,
Yeah.
anyone else?
Yes, Atlassian at their Team 25 conference. Big focus on AI there, too. They're embedding AI agents into their customer service management app, which is part of Jira Service Management. It leverages something they call their teamwork graph.
Okay, so AI aimed at improving customer support interactions. What can it do?
A bunch of things. It gives support agents more context about the customer, suggests personalized replies, recommends the next best action to solve a problem. It can even help write knowledge base articles or summaries using features like AI drafts and suggested topics.
So, making the support agent's job easier and hopefully improving the customer experience.
Right. And they're also launching these Rovo AI agents that work across their different products, Jira, Confluence, etc., to automate tasks and help teams collaborate better, even if they're using different tools.
That cross-platform capability is interesting, and Atlassian expects real business benefits from this.
Oh, yeah. They projected saving potentially $10 million a year internally on support costs and boosting their own customer satisfaction by about 6%. Those aren't small numbers.
Definitely not.
Yeah.
It shows the tangible impact these agents are expected to have. So it's not just the big platforms building agents. There's a whole ecosystem growing around them,
Yeah.
right? Training, tools.
Exactly. You need people who know how to build and manage these things. We saw Interview Kickstart, for example, launching specific courses, an Agentic AI Masterclass, a Build AI Agents course, aimed right at software engineers and product managers.
Training up the workforce.
Yeah, covering LLMs, prompt engineering, hands-on projects. They mentioned having over 700 instructors from big tech companies involved. Shows the demand.
And if these agents are more autonomous,
Yeah.
more unpredictable maybe, how do you monitor them? Standard tools might not cut it.
That's a huge point. Research was popping up around then about the need for better observability for agentic systems. We're talking beyond basic logs and metrics, things like dynamic trace analysis to see how the agent decided something, feedback streaming to correct it in real time, configuration tuning, even injecting synthetic tasks to test adaptability. It's a whole new monitoring challenge.
Understanding the why behind the agent's actions, not just the what, makes sense. And there was also talk about open source versus proprietary models for these agents.
Yeah, that debate surfaced. It really comes down to trust, especially for sensitive stuff like finance or legal work. Proprietary models can sometimes be black boxes.
You don't always know exactly how they work or what data they were trained on.
Right. Whereas with open source models, the argument is you get more transparency, you can potentially examine the weights, the training data, the code itself. That could build more confidence, particularly for businesses that need to audit or explain how these systems operate.
So transparency could be a big advantage for open source in certain domains. Interesting. Okay, so we've talked about what agents are and who's building them. Can we maybe paint a picture? How might these things actually change daily life?
Yeah, let's try a couple of hypotheticals. First, imagine you have a digital chief of staff.
Okay, I like the sound of that.
It's your personal AI agent. It manages your email, sorts it, drafts replies. It handles your scheduling, negotiates meeting times across different calendars. It updates your project trackers, maybe flags budget issues in your expense reports, does initial research for you. Basically handles all that administrative overhead.
Wow, so it frees you up to focus on, well, the actual important work.
Precisely. More focus, less cognitive load spent on the busy work.
I think everyone could use one of those. What's the second scenario?
Okay, picture the sentient shopper. You're walking by a store, maybe. Your AI agent, linked to your profile, recognizes where you are. It knows your past purchases, your online browsing, your wish lists, maybe even your style from social media.
Uh-huh. Hyper-personalization.
Exactly. So a personalized offer pops up on a digital display nearby. The agent has already checked inventory for your size and color. It gives you options by now for pickup, directions to the item in the store, maybe even summon a little robot to bring it to a fitting room.
That's seamless. Almost frictionless shopping.
Yeah, a future where tech really anticipates what you might want or need could totally change retail.
Those are compelling visions. Okay, so if agents are the intelligence, let's talk about the power source, the AI chips, because these advanced AIs need incredible processing power, right?
Oh, absolutely. The demand is just exploding. We're talking about a market for these specialized AI accelerator chips potentially hitting, what, $500 billion by 2028? It's staggering.
$500 billion, wow. And that week in April saw some absolutely huge news in this space, especially from the current market leader.
You mean NVIDIA? Yeah, that was the bombshell announcement. They committed up to $500 billion over 4 years to build AI infrastructure, specifically manufacturing and supercomputing capacity in the United States. That's a
Yeah.
massive strategic shift for them.
Right, because historically, their high-end manufacturing has been concentrated heavily in Taiwan, so bringing significant production to the U.S. is a really big deal. What are the specifics?
Well, they're working with TSMC, who's already making their new Blackwell GPUs in Arizona, but they're also partnering with Foxconn and Wistron to build huge new AI supercomputer factories in Texas.
Mhm.
And even the packaging and testing crucial steps are coming onshore, mostly to Arizona with companies like Amcor and SPIL. They're talking about millions of square feet of new facilities.
It's a full-stack domestic supply chain they're aiming for. And Jensen Huang, their CEO, wasn't shy about the ambition, was he?
Not at all. He basically said they're building the engines of the world's AI infrastructure right here in the US. It speaks volumes about the demand, but also, about supply chain resilience, geopolitical factors.
Absolutely. The push for more domestic semiconductor manufacturing, the tensions around global trade, this fits right into that larger context. It's clearly a strategic move on multiple levels.
Wait, NVIDIA, while dominant, isn't the only player innovating here, right? It's a global race.
Definitely not. We saw XPeng, the Chinese EV and tech company, unveil their own custom AI chip, the Turing chip.
Ah, so not buying off the shelf, but designing their own silicon.
Exactly. It's a 40-core processor designed specifically for their needs, powering AI in their cars, their flying cars, even their humanoid robot, which we'll get to later. They claim it can run massive 30 billion parameter models locally with something like 3 times the power of their previous chips.
That kind of vertical integration, designing the chip for your specific AI software, seems like a growing trend, more optimization potential.
It really is. And they mentioned mass production starting in China in Q2 2025, so they're moving fast.
So, established players, companies building their own. What about startups? Is there room for new challengers in this chip space?
There's certainly a lot of investment trying to find them. Venture capitalists poured something like $7.6 billion into AI chip startups just in late 2024.
Wow. Any specific examples that caught your eye?
One that stood out was Celestial AI. They're working on something called photonic fabric.
Photonic. So using light.
Yeah, basically using light pulses instead of electrical signals to move data between chips or components within an AI system. The idea is to overcome the bandwidth limits and latency issues you eventually hit with copper wires, especially in really large-scale AI hardware.
Faster data transfer, less bottlenecking. Sounds promising.
It does. And they just raised a big Series C around $175 million with backing from heavy hitters like AMD, Samsung, even Porsche SE. That kind of investment suggests serious industry belief in their approach. And they're just one example. There are others like Sima.ai and Fabrica, Halo, Grok, all exploring different angles.
Okay, so pulling back a bit, what are the main forces shaping this AI silicon landscape right now?
Well, first, as we touched on with NVIDIA, there's geopolitics and this idea of techno-nationalism. Countries wanting secure domestic sources for critical tech, like advanced chips. That's driving investment and potentially leading to more regionalized supply chains.
Right. The geography matters.
Second, the move towards specialized silicon. General-purpose GPUs are still key, but we're seeing more chips tailored for specific AI workloads, like XPeng's chip for mobility or Celestial's for data movement. The diverse needs of AI are driving hardware diversity.
One size doesn't fit all anymore.
Exactly. And third, maybe the most meta trend. AI is starting to be used to build the next generation of AI infrastructure.
You mean like NVIDIA using their Omniverse platform, their digital twin tech, to help design and optimize their new factories?
Precisely. Or using their Isaac robotics platform to develop robots for the manufacturing process itself. It creates this feedback loop where AI helps build better hardware, which then runs more powerful AI, and so on.
AI accelerating its own physical foundation. That's wild. Okay, let's do hypotheticals again. What could these future superchips enable for us?
Okay, first, think about creative work. Imagine instantaneous creative AI rendering. An artist types a complex prompt for a 3D scene, detailed characters, lighting, animation, and just renders instantly, photorealistically, as they type.
No more waiting hours or days for a render.
None, just pure, fluid, creative flow. It would completely change digital art, filmmaking, game design.
Wow. Okay, what's another one?
How about city-scale predictive traffic optimization? Imagine an AI running on these powerful chips managing the entire traffic flow of a major city.
Like all the traffic lights.
Everything. Analyzing data from cameras, sensors, connected cars, predicting jams before they happen, optimizing signals in real time, rerouting vehicles dynamically, giving personalized guidance to drivers.
The end of gridlock.
Maybe not the complete end, but potentially dramatic reductions in commute times, fuel consumption, frustration, making cities much more efficient.
We can dream. Okay, so we've got smarter AI agents, incredibly powerful chips. Let's talk about the glue holding it together, the software. How is AI changing the software we interact with?
Well, the big shift is that AI isn't just in standalone apps anymore. It's becoming deeply embedded within the major platforms and tools we already use. It's becoming a feature, almost an expectation.
Right, woven into the fabric. We saw Alibaba Cloud making a big global push that week, didn't we?
We did. They expanded access to their Quinn family of LLMs internationally, starting in Singapore. And they rolled out significant upgrades to their AI platform, PAI.
What kind of upgrades are we talking about? Things relevant for businesses using their cloud?
Yeah, several key things. They improved how PAI handles distributed inference, basically, running really big models across multiple machines more efficiently. They reported big gains in speed and how many users could access it simultaneously.
So better performance for large-scale AI.
Exactly. They also massively expanded their PAI model gallery, nearly 300 open-source models now deployable with little or no code needed, making advanced AI much more accessible.
Lowering the barrier again.
And they pushed AI deeper into their core data products, like integrating Quinn AI capabilities directly into their PolarDB database, so you can do things like RA, semantic search, text embedding right inside the database.
So you don't need to move data around as much between the database and a separate AI service. Streamlines things.
Precisely. Reduces complexity, reduces latency. They also connected their AnalytiDB data warehouse to their Model Studio, again, making it easier to link private data with AI models. And they launched new AI-powered SaaS tools.
Oh, yeah. Like what?
There was AI Doc for intelligent document processing. They mentioned using it for ESG reports. Smart Studio for creating content, text-to-image, text-to-video, even virtual try-ons for e-commerce. And an AI search assistant on their own site to help smaller businesses find the right cloud services. It's a very integrated approach.
Really baking AI into everything. And we already mentioned Atlassian doing similar things across Jira, Confluence, Loom, embedding AI into existing collaboration workflows.
It's definitely a major trend. But it's not just the giant platforms, is it? We're also seeing lots of specialized AI tools making an impact.
For sure. We saw T-Tech winning awards for AI tools, delivering real results. Their T-Tech Perform coaching tool apparently boosted sales conversion by 10% and cut call times by 6% for a client.
Tangible ROI.
Right. And their Addy AI voice translation tool cut interpreter costs by up to 80% in some healthcare and education settings. That's huge.
Those specialized solutions are really proving their value. And we saw other niche applications too, right? Like AI analyzing videos to help assess Parkinson's symptoms.
Yeah, and AI for real-time sign language translation, tackling very specific, important challenges.
And then there's the whole category of tools just making creativity and productivity easier for everyone.
Oh, yeah, the list keeps growing. Canva's magic features, Jasper for writing help, Pictory for video summaries, Murph or Lovo.ai for voice generation, Synthesis for video presenters, Aragon for headshots.
Plus the ones many people already use daily. Grammarly, ChatGPT, Copy AI, Descript for editing audio-video, Otter.ai for meeting notes. It's becoming part of the standard toolkit.
So looking at all this software activity, what are the underlying trends?
Well, definitely AI is a feature, like we said. AI becoming a standard part of existing software and not just a separate thing. Also, the maturation of vertical AI, those specialized tools like T-Tex showing real measurable success in specific industries.
Solving specific business problems effectively.
Exactly. And finally, just significant progress in multimodal AI. Tools handling text, images, video, audio, even gestures. That capability is unlocking a lot of new software possibilities.
Okay, let's try hypotheticals for software. How could this smarter software make complex things simpler?
All right. First, imagine an AI-powered scientific discovery assistant.
Oh, ambitious.
Yeah. A software suite that pulls together diverse biomedical data research papers, experimental results, genomic data, clinical trial info. It cross-references everything, suggests new hypotheses, helps design experiments, even drafts research papers. Basically, supercharging the research cycle.
Accelerating breakthroughs by connecting the dots faster. That would be incredible. What's another one?
How about effortless, multilingual business operations? Imagine AI translation seamlessly built into customer support chat, email, even e-commerce product descriptions. A small business could instantly communicate with customers anywhere, localize their website automatically.
Making it easy to go global, even for tiny companies.
Exactly. Removing language as a major barrier to international business, that could be truly democratizing.
Okay, so we've covered agents, chips, software. Let's look even further out now to the really cutting-edge stuff where AI is meeting quantum computing and robotics. Still early days, but potentially revolutionary, right?
Absolutely. These intersections hint at capabilities far beyond what's possible today. It's where things get really mind-bending.
Let's start with quantum. There was that report about Chinese researchers using their Origin Wukong quantum computer 72 qubits to actually fine-tune an AI model, a big one, like 1 billion parameters.
Yes, that was a fascinating result.
Yeah.
They reported that using the quantum computer allowed them to significantly reduce the number of parameters in the model by like 76%, while actually improving its performance on a math task. Training loss went down, accuracy went up.
So potentially using quantum to make AI training more efficient. Less computationally intensive, maybe less energy hungry.
That's the implication. It suggests quantum might offer shortcuts or new approaches for optimizing these huge AI models, even if it's just for specific parts of the training process initially. It could also enable totally new kinds of quantum-native AI algorithms down the line.
And NVIDIA, who we normally associate with classical GPUs, seems to be taking quantum more seriously now, too.
They are. They held their first dedicated Quantum Day event around that time and launched the NVIDIA Accelerated Quantum Research Center, NVAQC, in Boston. Their focus seems to be on hybrid systems.
Hybrid, meaning quantum and classical computers working together.
Exactly. Integrating quantum processing units, QPUs, with their GPU-based systems like the GB200. The idea is to use classical power to help tackle challenges in quantum, like error correction, and also to develop new quantum algorithms that leverage both types of computing. It's a pragmatic approach to making quantum useful sooner.
So the synergy could unlock things. Like what? What's the long-term dream for quantum AI?
Well, huge potential in areas like drug discovery and materials science, simulating molecules with incredible accuracy, transforming finance through complex risk modeling and optimization, maybe even accelerating the path towards artificial general intelligence, AGI, by tackling problems classical computers struggle with.
Big, transformative possibilities. Okay, let's switch to the other intersection. AI and robotics. XPeng's Iron Robot definitely made a splash.
It did. A humanoid robot powered by their own Turing AI chip. Pretty sophisticated 60 joints, lots of degrees of freedom, powerful onboard processing, a 720-degree vision system.
Designed for what kinds of tasks?
They're initially targeting smart factories and potentially retail environments, tasks that require dexterity, mobility, and visual understanding. It represents a big step towards more capable, general-purpose robots.
And it's not just humanoids, right? There are platforms emerging, too.
Right. NVIDIA's Isaac GR00T platform, for instance, provides foundational models and tools for developing all sorts of intelligent robots, especially for manufacturing and logistics. And research labs are constantly pushing boundaries. Tiny, agile robots, soft robots for tight spaces, robots learning complex grasping from observing animals.
So it feels like we're moving towards embodied AI. AI that doesn't just live in the cloud, but can perceive, reason, and act in the physical world.
That's exactly the term. Robots are becoming the physical bodies for increasingly sophisticated AI minds. They need to understand the messy, unpredictable real world and interact with it effectively.
Okay, so bringing it all together, AI, quantum, robotics, let's try one last pair of hypotheticals. What does that combined future look like?
Right. How about quantum accelerated materials discovery? An AI system uses a quantum coprocessor to rapidly simulate complex molecular interactions, designing, say, a novel catalyst for producing cheap green hydrogen, something that would take classical computers centuries, done maybe in days or weeks.
Directly accelerating the clean energy transition through this combined power. Wow. Okay, one more.
Let's imagine a fully autonomous AI robotic logistics network. An AI oversees an entire distribution center. Agile little robots zip around retrieving items. Humanoid robots handle delicate or complex packing. Autonomous trucks and drones manage deliveries. The AI optimizes everything in real time, adapting instantly to demand changes or disruptions.
Complete end-to-end automation, managed by AI, executed by robots. That's a vision of radical efficiency.
It really is. So, looking back at that single week in April 2025, the pace is just breathtaking, isn't it? AI agents getting more capable, the chips getting exponentially more powerful, the software getting smarter, and these early glimpses of quantum and robotics convergence.
It really feels like the pieces are snapping together, and like you said earlier, it's not isolated progress. Advances in chips enable better agents, which drives demand for smarter software, which requires better chips.
It's a self-reinforcing cycle,
Yeah.
a feedback loop that's compressing innovation timelines dramatically.
Ah,
We're living through a genuine technological renaissance, it feels like.
yeah. This AI-powered future isn't some far-off dream anymore. It's arriving, and it's arriving fast. It's going to change industries, economies, probably our daily lives in ways we're only starting to grasp.
Absolutely. The transformation is underway, and the momentum is undeniable.
So I guess the main takeaway for everyone listening has to be, get ready. This accelerated future driven by AI in all these different forms is coming, and we all need to be prepared for the changes ahead.